Hello everyone, and as in the previous lecture we have been discussing about histogram, but in this one we will be also going in detail about the different properties, characteristics of histograms along with a two-dimensional histogram, that is a bivariate plot, and also we would be discussing some statistics related with satellite images. So, how we can use that information. So, I will be going quickly through this histogram because some part we have already discussed. Basically, histogram is a graphical representation and that brings a visual impression of the distribution of data rather than looking just at digital numbers, which becomes difficult to understand how the pixel values are distributed against a image. But if we plot a histogram, which is easy to do it, on y-axis we get the frequency, on x-axis we get the pixel value, and once it is done, then a lot of information, as also discussed in previous lectures, can be gathered about a particular image. So, histograms provide a basically univariate because histograms of individual bands, individual image is there, that is why it is a univariate, and if we want to see the histogram of 2, then it would be bivariate or multivariate are also possible. So, one variable description of data, how data is distributed, and that tells also the how the quality of an image taken by a sensor. So, that can be seen. An image histogram is basically which is a not only graphical representation, but also it tells you that whether there are lighter objects or darker objects present in the image, and basically it plots the each pixel of that image. Histogram, why histogram need to be done or studied, assessed, that is the basic information it provides, and of which is start of a image processing or image enhancement techniques. And because there are various special domain processing steps we might be taking, and to understand or choosing a best one, first we have to understand the histogram. And therefore, as also mentioned in previous lecture, some time should always be spent on image histogram and statistics before we go for any kind of image enhancement techniques. When we enhance images, basically what we are doing, we are manipulating with the histogram, and we will be seeing some examples also. And the histogram provides the information about the image statistics as well, mean, median and mode, minimum value, maximum value, what is the maximum frequency, that kind of information can be retrieved with the histogram. If there are two peaks, it tells something else. If there is single peak, that also, if distribution is Gaussian distribution, then it tells different thing. So, that is why it is important, and the information derived from histogram are quite useful in many other applications of digital image processing or in remote sensing, maybe in image compression and segmentation. So, image compression, why? Because this image compression is required to reduce the size of image without compromising the quality of the image. That is the purpose here for us. And if there is a homogeneity present in the image, lot of compression, image compression can be achieved. And if there is a lot of heterogeneity is present among the pixel values, then high image compression cannot be achieved. So, if I study a histogram, I can assess whether the distribution is heterogeneous or homogeneous. If it is homogeneous, I know now that that image will provide a particular compression technique will provide me better results. So, that is why it can be used also for image segmentation. In the same way it can be used. So, the understanding histogram has got various applications. Now, basically it is a frequency distribution in a bar graph, and that displays how often observed values fall within certain intervals or classes. So, these towers which you see are basically intervals or different classes are there. We can also control number of classes, how these things should be displayed, and relative portions of data and that falls in each class is represented by the height of each building or bar. So, that for example, a histogram is shown here, and that is showing basically frequency distribution in 10 classes. So, it depends on my requirements. I want more number of classes, or even if it is 8-bit scenario, then I can have even 256 classes, variation between 0 to 255, and I can see the things accordingly. Same time also you get the minimum value, maximum value, mean, mode, median, standard deviation, other statistical parameters like skewness, kurtosis, and all those things can also be identified from there. So, that is why histogram is important. Histogram brings measures of strep, basically how pixel values are distributed in an image. Spread of points around the mean is another characteristics of display histogram or frequency distribution. As you can see these red curve is showing less distribution around the mean, whereas the white curve is showing more distribution around the mean. And the variance and standard deviation for the black frequency distribution, as you can see, is the greater than those of the red frequency distribution. If you are having skewedness present in your image, some a bright part are more or dark part are more, then in histogram you would see a skewed representation, skewed distribution in the image. So, that can be also the shape of histogram tells about the skewness present, and this coefficient of skewness is basically measure of symmetry of distribution. So, generally you do not get a symmetric histogram, generally you get non-systematic histogram or distribution, and therefore there will be skewness either towards the smaller values or large values. In this example, skewness towards the lower value, and therefore mean, median and mode will be located at different places. So, that also tells that there are I can while going through this histogram I can tell that there are a large number of pixels which are having lower pixel values compared to the values which are having high pixel values, and if it would have been reversed, then a different interpretations will come out from this one. Now, we see in a real example that histogram when it represent a relative frequency of occurrence of various grace levels in that image. On the right side you are seeing the image, on the left side you are seeing the histogram distribution. In this case, the raw image histogram is occupying the full range available to us, that is between 0 to 255. Again it is a 8-bit scenario, and that means if I go for simple linear stretch, I do not have much maneuverability available to me, because I am having brighter parts, I am having darker parts as well, brighter parts as well, and that is why there are two areas or two peaks in my histogram there, and some values are also here. So, if I want to improve the contrast in the image, then I have to ignore certain the tail values on both ends to improve the contrast. So, that way histogram also becomes important to assess that situation. So, image, and generally for individual bands we have to see, because individual band will have different histograms, this one has to remember. So, instead of even if you are working on a color composites, but while studying histogram, individual histogram must be seen, because different band will have a different distribution of pixel values. So, in a image which is of a single band image in remote sensing data is representation of how the radiant energy reflected or emitted by the surface is distributed in two spatial dimensions. And the energy, as you know, is expressed as dn or digital number or pixel value, which is displayed as representation by a variation in the brightness showing. And since our eye is capable of distinguishing only about 30 gray labels in a black and white image, and about 256 whereas we are having display of 256. So, we might be displaying, but our eyes are sensitive only to 30 gray labels. Does not matter because when we go for image classification or other processing of images, then the machines will take care about this distinguishing 256 gray labels rather than 30. So, an image can be also expressed statistically as probability of finding digital number of a given value within it, and this measure is properly termed as probability density function PDF. And this PDF is represented most conveniently by a histogram of number of pixels regardless of spatial position within an image have a particular brightness value or pixel value or digital number. Now, here this is PDF, the probability density function of an image can be expressed in two forms, either A through this histogram or maybe a cumulative way like on the bottom side. So, one has to be careful, this is frequency and this is cumulative frequency. So, the first one, this A, the top one is the number of frequency of pixels normal histogram, and whereas the bottom one, the B part, is the vertical axis is the cumulative frequency of pixels having DN number, and this cumulative frequency. So, the maximum DN is 100 here, and here you will have the real frequency distribution. So, the same distribution of DN appears as peaks and sometimes troughs as in case of A, and as changes the gradient roughly S-shaped curve in B, because this is how the distribution in original histogram is. Now, this curve in cumulative frequency versus pixel values will vary depending on again image to image. So, one can also plot like this and try to understand the distribution of pixel values through this PDF also. So, this indicates basically the shape indicates the contrast and homogeneity of the scene. That is important because homogeneity is useful not only in image enhancement, but also in image compression, for image compression purposes. So, if a scene is a homogeneous surface like of a desert or a snow covered area or ice shield areas, a low contrast will produce a histogram with a single or a sharp peak. And if you are having a broad peak, single broad peak, which suggests that homogeneity but a wide range of contrast. So, a histogram tells lot many things. That is why I have been saying that histogram is important. There are some other values or other advantages are there with 1 peak, 2 peak and 3 peaks, and tails also, like the presence of tails and degree of asymmetry of the peak both indicate important structural features in an image that will rarely be obvious from a picture itself. So, these structural features might be there because of some features along or asymmetry or tails, like in one example you have seen that tails also like this one, you are having tails also having pixel values. So, different kinds of terrain, natural conditions or such scenarios sometimes produce contrasted histograms, and both these images are of Landsat MSS band 7. The brighter areas here, the salt areas, salt flats, and dark areas are the lavas which you are seeing here, two different ground features. In the Andes are more common surface than intermediate digital values. So, in intermediate digital values which are falling here are less compared to low values or high values. So, the histogram, as you know, has two peaks and we say bimodal. In case of the bottom example, here you do not have that kind of contrast. So, you see the distribution single peak. So, the image is also from the same area, but as a simple probability distribution function here, which gives a nearly symmetrical unimodal histogram, which you can see on the bottom left, even though the areas with distinctly different digital values are there. So, not only it is telling the distribution, but it is also telling inbuilt contrast within an image. Now, when we go for multispectral, then we go for a scatter plot or a two-dimensional histogram, if you wish to call. So, this is multispectral data example, which can be expressed or this histogram through multidimensional histogram. Two axes are having two histograms and each pixel value is distributed in this space. So, both axes are having value dynamic range between 0 to 255, y-axis is also having 255. So, pixels values of two bands, one is the red band in this example and V and I are very near infrared band. These have been used and displayed. So far what we have been seeing of histograms of single band. Now, when we go for the, two bands in this example, then now we can even we can identify how two bands are correlated. That is the first purpose of doing this exercise, is plotting a scatter plot or seeing a multi dimensional histogram. So, in this one, by identifying the areas, because represented by the low pixel values in one band, that is in red band, and relatively higher pixel values in the infrared band, we can identify that these pixels might be belonging to the vegetation. Similarly, this area, because in both bands they are having higher values, relatively higher values, so might be bare rocks and soils. Because if it would have been vegetation cover, then those signatures will come here, those pixels will be plotting their position here. And if I am having very low values in infrared channel and relatively higher values in red band, then I am probably looking a turbid water with lot of suspended particles or turbidity. So, moving from one dimensional histogram, when two dimensional histogram, many more things can be seen in this two dimensional histogram. So, these are bivariate plot, scatter plot, two dimensional histogram, again very useful. So, whenever you are going for multispectral analysis instead of single band analysis, histogram is sufficient, but when you go for multispectral analysis, it is better first to plot a bivariate plot and try to understand not only the distribution of individual bands, which can be seen here through these histograms, but how they are related, how pixel values are related in different bands. Here one visible band, one in infrared band, of course things are completely different in these two. So, this will allow you to identify different surfaces, as I have just discussed, vegetation, bare rock, soil and turbid water, by looking these two bands histograms. Now, density of plots of individual pixels is a measure of where peaks is one dimensional histogram coincides. So, if there is a very good relation between two bands, then there will be high density of pixels plotted in a small area. That means they are correlated. Correlation will also come when they are in a linear fashion. So, highly correlated data or classes of surface materials that have similar appearance on different bands or images or two bands plot nearly a straight lines on two dimensional histograms. So, if there is a choice to drop one band for my color composite, I can do it very easily if I find that two bands, two edges, say Landsat MSS 4 and 5 are highly correlated, and in color composite I need only 3 bands. So, one band I can drop it because they are highly correlated and there is no need of putting them in my color composite. So, this correlation among bands is also important in multispectral analysis. So, whereas poorly correlated data show as a shapeless clouds of points, no linear distribution of pixel values in two-dimensional histogram, and which overall poor correlation stems from the scene being a mixture of variably vegetated surface, bare rock, soil and water, and that example you have seen earlier like this one. So, there is no linearity in the distribution of pixel values is there. Now, the rocks, different rocks and soils show high correlation that occur throughout the scene of arid terrain. If you are having a dry terrain where you do not have the vegetation cover, then they may show almost similar characteristics. Another thing which is used in digital image processing, a concept which is basically lookup table or LUT. The purpose here is not to modify the original image, but when image is displayed in between, a lookup table is created. So, when you want to save a stretched image, you generally do not save the image, you just save the lookup table, and therefore, you do not occupy lot of space on your hard disk. So, that is the advantage of lookup table. So, if your image is occupying 100 MB, whereas lookup table may require to maybe 100 kilobyte. So, by which you can save lot of space and it becomes faster for display as well. So, lookup table concept have been implemented in almost all softwares, and it becomes very advantageous not to flood your hard disk with lot of data or duplicate data or original image, then enhanced image, one more enhancement, there might be 10 versions and you are of the same image. So, rather than saving like this, you save the original image and lookup tables for all other processed part. So, that makes things very easier. So, basically it is a two-dimensional table, and lookup maps which is input RGB values to output RGB using color transformation function as shown here. For example, if I take this red values here, then it is projected here. So, in original distribution, I am having values distributed say between only this dynamic range. But when I go through the lookup table, now I have distributed these values between this much of dynamic range. If I see the values in that one, then they are around 1024 values are around 1024, this yellow, green and red. Whereas now these values are distributed, here is the yellow, here is the green and here is the red. So, they are occupying now large dynamic range compared to my input, and only through this table, lookup table, I will save in my machine my result only the lookup table, not the original image. Original image will be always there, but processed image will not be saved. Only the processed lookup table will be saved. So, these are specified in tabular form using a color transformation function which is given like this, the LUT function x, y, these are, and RGB x, y, the location of individual pixels, and when output you are having again x, y, the location has to be intact, and then RGB how changes have occurred, and likewise you get this lookup table. So, this brings to the end of this discussion about histograms. We have completed discussion on histograms. A simple statistics which is also used in image analysis, image enhancement technique, then bivariate plot, scatter plot or two-dimensional histogram and their applicability, how it is useful, and finally the concept of lookup table which have been implemented by various standard software. Very useful not to flood your hard disk with a lot of image, original image, enhanced image and then filtered image and other things. Just save the lookup table. So, this brings to the end of this discussion. Thank you very much.